Imagine everything you see, everything you touch, everything you love, all of it, nothing more than lines of code. Every sunset, every sound, every thought, not real, but data. The mountains, the stars, your memories. Digital illusions rendered by something far beyond human understanding. It sounds like science fiction, the plot of The Matrix. But what if it isn't? What if the world you live in is not the base reality, but a simulation? The idea that life could be an illusion is not new. Humans have asked it for thousands of years, long before computers, before science, before logic itself had a name. It began with a philosopher sitting in the dust of ancient Greece. His name was Plato. Plato described a story known as the allegory of the cave. He imagined prisoners chained inside a cave from birth, facing a wall. Behind them, a fire burns, and between the fire and the prisoners are objects being moved by unseen hands. The prisoners see the shadows of those objects on the wall, and to them, those shadows are reality. They know nothing of the fire or the world outside the cave. They believe the illusion completely. For Plato, this story was not just a metaphor, it was a warning. He believed that humans mistake appearances for truth, that what we call reality may only be a shadow of something far greater, something beyond comprehension. 2,000 years later, another philosopher, René Descartes, faced the same dilemma. He questioned everything he could see, hear, and feel. How do I know that what I experience is real? How do I know my senses aren't deceiving me? What if everything around me is a dream? Or worse, a deliberate illusion? Descartes imagined a powerful being, a malicious demon, that could trick his mind into believing in a false world. A world where every sensation, every sound, every breath was fabricated. The only thing he could be sure of was the existence of his own thoughts. I think, therefore, I am. But beyond that, reality itself could be a lie. For centuries, those questions remained philosophical curiosities, thought experiments for poets and scholars. Then, in the 20th century, something extraordinary happened. Humanity created machines that could simulate. The birth of computers changed everything. For the first time, we could model reality mathematically, weather systems, physics, entire galaxies, inside silicon chips. Video games turned imagination into experience. Virtual reality blurred the line between physical and digital. Every year, our simulations became more convincing, more complex, more alive. And quietly, a few scientists began to wonder, what if the same principle applied not just to games, but to everything? In 1960, computer pioneer John von Neumann theorized about the possibility of a self-replicating system, a machine that could build copies of itself endlessly. The idea planted a seed. If intelligence could evolve in machines, could machines one day create worlds? By the late 1970s, physicist Konrad Zuse, the inventor of the first programmable computer, proposed something radical, that the entire universe might be running on computation. He called it rechnender Raum, or calculating space. His theory suggested that physical reality itself was built from information, a vast cosmic program. Others followed. Edward Fredkin, a computer scientist at MIT, argued that the universe was not made of matter, but of data, that atoms were not physical objects, but bits of information processing. He believed reality was essentially a digital system, governed by logic and computation. To many scientists, it was madness. But decades later, the world began to catch up. By the early 2000s, video games had evolved from pixelated screens to immersive 3D worlds indistinguishable from life. Artificial intelligence began to make decisions, create art, and even mimic human thought. Neural networks learned to learn. And that's when an Oxford philosopher named Nick Bostrom reignited the question that had haunted humanity for millennia, not as philosophy, but as mathematics. In 2003, Bostrom published a paper that sent shockwaves through academia. It was titled, "Are You Living in a Computer Simulation?" His argument was simple, but devastating. He said one of three statements must be true. First, humanity will go extinct before reaching the level of technology capable of simulating entire universes. Second, advanced civilizations will choose not to create simulations of their ancestors. Or third, if they do create them, then simulated beings like us will vastly outnumber the original biological humans. If the third statement is true, the conclusion is inescapable. Statistically, it's almost certain that we're living inside a simulation. Bostrom wasn't suggesting faith or fantasy, he was using probability. If one civilization in the entire cosmos had created simulated realities, then the number of simulated minds would dwarf the number of real ones. And if that's true, then the odds that you're real are almost zero. The paper sparked outrage and fascination in equal measure. Scientists dismissed it as philosophical speculation, but others, including some of the brightest minds in technology, took it seriously. Elon Musk, the CEO of Tesla and SpaceX, famously said in an interview, "The odds that we're living in base reality are 1 in billions." Neil deGrasse Tyson, the astrophysicist known for his skepticism, admitted that simulation theory is hard to argue against. Even Nobel-winning physicists have begun exploring how quantum mechanics might hint at a digital universe. Because here's the strange thing, the deeper we look into reality, the more it behaves like code. At the smallest scales of existence, the universe doesn't flow continuously. It comes in discrete chunks, like pixels on a screen. Space and time themselves seem to be quantized. Imagine everything you see, everything you touch, everything you love. All of it, nothing more than lines of code. Every sunset, every sound, every thought, not real, but data. The mountains, the stars, your memories, digital illusions rendered by something far beyond human understanding. It sounds like science fiction, the plot of The Matrix. But what if it isn't? What if the world you live in is not the base reality, but a simulation? The idea that life could be an illusion is not new. Humans have asked it for thousands of years, long before computers, before science, before logic itself had a name. It began with a philosopher sitting in the dust of ancient Greece. His name was Plato. Plato described a story known as the allegory of the cave. He imagined prisoners chained inside a cave from birth, facing a wall. Behind them, a fire burns, and between the fire and the prisoners are objects being moved by unseen hands. The prisoners see the shadows of those objects on the wall, and to them, those shadows are reality. They know nothing of the fire or the world outside the cave. They believe the illusion completely. For Plato, this story was not just a metaphor, it was a warning. He believed that humans mistake appearances for truth, that what we call reality may only be a shadow of something far greater, something beyond comprehension. 2,000 years later, another philosopher, René Descartes, faced the same dilemma. He questioned everything he could see, hear, and feel. How do I know that what I experience is real? How do I know my senses aren't deceiving me? What if everything around me is a dream? Or worse, a deliberate illusion? Descartes imagined a powerful being, a malicious demon, that could trick his mind into believing in a false world. A world where every sensation, every sound, every breath was fabricated. The only thing he could be sure of was the existence of his own thoughts. I think, therefore, I am. But beyond that, reality itself could be a lie. For centuries, those questions remained philosophical curiosities, thought experiments for poets and scholars. Then, in the 20th century, something extraordinary happened. Humanity created machines that could simulate. The birth of computers changed everything. For the first time, we could model reality mathematically, weather systems, physics, entire galaxies, inside silicon chips. Video games turned imagination into experience. Virtual reality blurred the line between physical and digital. Every year, our simulations became more convincing, more complex, more alive. And quietly, a few scientists began to wonder, what if the same principle applied not just to games, but to everything? In 1960, computer pioneer John von Neumann theorized about the possibility of a self-replicating system, a machine that could build copies of itself endlessly. The idea planted a seed. If intelligence could evolve in machines, could machines one day create worlds? By the late 1970s, physicist Konrad Zuse, the inventor of the first programmable computer, proposed something radical that the entire universe might be running on computation. He divided into indivisible units. Information, not matter, appears to be the true foundation of everything. In 1948, Claude Shannon, the father of information theory, discovered that all communication, all signals, could be reduced to binary digits, zeros and ones. Decades later, physicists realized that the same could be true for nature itself. Every particle, every quantum state, could be represented as a set of information bits. The laws of physics might not describe energy and matter at all. They might describe how data is processed. Imagine a universe where the laws of physics are the source code, quantum mechanics is the operating system, and reality is the rendering of that code, only visible when observed, just like a computer simulation. And there's another detail that makes it even stranger. The universe runs on limits. The speed of light, for instance, is a fixed maximum. Nothing can go faster. In digital systems, that's called a processing cap, a limit on data transfer. The Planck length, the smallest measurable distance, is like a pixel size for space. The Planck time, the smallest possible unit of time, acts like a frame rate. Everything beyond that is blank, undefined. It's as if our world is running on an engine. In recent years, scientists have started to look for evidence of this. Physical signs of the grid, the lattice, the digital fabric of the cosmos. Experiments at Fermilab in the United States are searching for something called space-time jitter, a subtle vibration in the universe that would reveal the pixelation of space itself. If they find it, it would be the first direct clue that the world we see is not continuous, but computed. The implications are staggering. It would mean that everything we know, the Big Bang, evolution, consciousness, might be the result of code running on some incomprehensibly advanced system. It would mean that the laws of nature are not discovered, but designed, and it raises a question that chills the spine of every scientist who dares to ask it. If the universe is a simulation, who or what built it? Was it our distant descendants recreating their ancestors to study their own history? Was it an alien civilization testing cosmic-scale experiments? Or something far beyond comprehension, a creator that exists outside of space and time, watching its creation unfold like a movie? No one knows. But what makes this theory impossible to dismiss is not faith, not science fiction, but the mathematics of probability and the eerie precision of our universe. Because the more we understand the code of reality, the more it looks like it was meant to be understood. And as technology advances, as our own simulations grow more lifelike, one truth becomes increasingly clear. If humans can create simulated worlds within decades, then whoever created ours may already be watching. The deeper science looks into the universe, the stranger it becomes. What once seemed solid and dependable, matter, energy, space, and time, begins to dissolve into something abstract, something that looks far more like information than reality. Every discovery in modern physics seems to whisper the same impossible suggestion. The universe behaves as though it is processing data. At the turn of the 20th century, physics was supposed to have everything figured out. Newton's laws had explained motion and gravity. Maxwell's equations had unified electricity and magnetism. Scientists believed they were closing in on a perfect description of the world. Then, at the smallest scales of matter, everything broke apart. When researchers studied atoms, they found that electrons didn't orbit like planets around the sun. Instead, they existed in clouds of probability, appearing in one place only when observed. The universe, it seemed, did not commit to a reality until someone looked. This was the birth of quantum mechanics, a theory so bizarre that even its founders could barely accept it. Niels Bohr once said, "If quantum mechanics doesn't shock you, you don't understand it." Albert Einstein, unsettled by its implications, famously protested, "God does not play dice with the universe." But the experiments didn't lie. The double-slit experiment became the most haunting of all. Scientists fired single particles, electrons or photons, through two slits in a barrier. When unobserved, the particles created an interference pattern on the screen behind them, as if each particle had passed through both slits simultaneously, behaving like a wave. But when scientists measured which slit the particle actually passed through, the pattern vanished. The particle suddenly behaved like a solid object going through one slit or the other. It was as though the universe changed its behavior depending on whether it was being watched. In a simulation, this makes perfect sense. To save computational power, a simulated world doesn't render every detail at once. It generates only what the observer can see. Look away, and the system stops processing that area. Look back, and it renders again. The resemblance to quantum observation is eerie. Physicists have wrestled with this mystery for a century. Why does the act of measurement affect reality? Why does the universe seem to care about consciousness? Some believe it's coincidence. Others, like theoretical physicist John Archibald Wheeler, thought it might be the key to everything. Wheeler called it the participatory universe, the idea that reality requires observers to exist, that we help bring the universe into being simply by looking at it. But what if the reason observation matters is because the universe itself runs on information? To understand this, scientists turn to the smallest possible scale, the Planck scale. It's the resolution limit of the universe, the smallest measurable units of space and time. Below this scale, physics stops working. You can't have half of a Planck length or half of a Planck time. It's as if the universe is built out of discrete pixels, just like a digital screen. At this level, space is not smooth and continuous. It's grainy, quantized. The equations describing it are eerily similar to how computers process data. Binary decisions, bits of information switching between states. In 2012, theoretical physicist James Gates at the University of Maryland discovered something that stunned the scientific community. While studying supersymmetry, an advanced model in particle physics, he found embedded in his equations a series of patterns identical to error-correcting codes, the same kind used in computer processors to detect and repair data corruption. Gates called them adinkras. To him, it suggested that the laws of physics themselves were written like software, code running flawlessly across reality. When asked what it meant, he said, "I cannot tell you that we are living in a simulation, but I can tell you that something very strange is going on." This wasn't mysticism, it was mathematics. Around the same time, researchers began asking another question. Could the universe be a quantum computer? Every interaction between particles, every exchange of energy, every collision, every atom forming and breaking apart could be interpreted as a computation. The laws of physics might be algorithms. The cosmos itself might be processing information at unimaginable scales. Physicist Seth Lloyd from MIT calculated that the universe could have performed roughly 10 to the power of 90 operations since the Big Bang, operating on about 10 to the power of 80 bits of information. Those are the numbers of a truly colossal supercomputer, one that dwarfs anything humanity could ever build. And yet, every step in physics continues to reveal patterns of efficiency. The laws of nature always choose the simplest path, the lowest energy, the shortest time. It's as if the universe optimizes itself, like code minimizing for processing power. Even the structure of the cosmos resembles data architecture. Galaxies cluster in vast filaments, separated by immense voids, patterns that look strikingly like neural networks or circuit boards when visualized in simulations. Some scientists have joked that if you showed a cosmologist and a computer engineer a map of the universe and a brain scan, they might not be able to tell which was which. And this brings us to perhaps the most unsettling idea of all, the holographic principle. In the 1990s, physicists studying black holes discovered something impossible. When matter falls into a black hole, its information seems to vanish, a direct violation of the laws of quantum mechanics, which state that information can never be destroyed. To resolve the paradox, scientists propose that all the information swallowed by a black hole isn't lost. It's encoded on its surface, stored as a two-dimensional pattern. The three-dimensional world inside the black hole is, in a sense, a projection of that surface data. Later, theorists like Leonard Susskind and Juan Maldacena realized this might apply not just to black holes, but to the entire universe. The idea was revolutionary. Our three-dimensional reality might be a hologram, projected from a distant, two-dimensional boundary containing all the information about our world. If true, then what we call space is an illusion. Depth, distance, even time could be emergent properties of a deeper informational layer, a cosmic screen. The deeper physicists looked, the more the universe began to resemble a vast, elegant data structure. Yet skeptics argue that none of this proves simulation. Perhaps the universe simply acts like a computer, but isn't one. Still, others insist the evidence is piling up in ways that can't be ignored. At Fermilab, near Chicago, researchers are conducting the holometer experiment, using ultra-sensitive laser interferometers to detect holographic noise, tiny fluctuations in space-time that would reveal if the universe has a finite resolution, like pixels. If such noise exists, it would mean the universe has an underlying grid, a computational limit. So far, the results are inconclusive. But every year, new tests are being proposed. Some researchers suggest that cosmic rays, the highest energy particles in the universe, could reveal signs of the code. If there's a maximum energy threshold beyond which particles can't exist, it might suggest that reality's simulation has an upper processing limit, just as video games have a maximum render capacity. Others look to quantum entanglement for clues. When two particles become entangled, they share information instantly, across vast distances, as if bypassing space entirely. Einstein called it spooky action at a distance. But in a digital system, that kind of communication makes sense. Entangled particles could simply be referencing the same data stored elsewhere in the code, updating simultaneously because they're part of the same system. Every piece of evidence leads to the same haunting pattern: quantum mechanics, cosmic structure, information theory. All of them fit neatly inside the framework of computation. And yet, there is a paradox. If we are simulated, how could we ever prove it? If the simulation is sophisticated enough, every test we design would also be simulated. Every measurement, every observation, every thought would be part of the system itself. We could only ever discover what the simulation allows us to discover. The moment we reached too close to the edge, the system could simply rewrite itself, conceal the truth, or delete the evidence altogether. Philosophers call this the epistemic trap, a cage of knowledge. A simulated being can never be sure of its own nature, because its understanding of reality depends on the simulation's rules. Still, scientists keep searching, because to them, the question isn't only whether we're simulated, it's whether simulation could explain the greatest mysteries of existence, why the laws of nature are so perfectly tuned for life, why the universe seems to be designed, and why consciousness itself defies explanation. Every constant in physics, the strength of gravity, the charge of the electron, the mass of the proton, is perfectly balanced. Change any one of them slightly, and the universe would collapse. It's called fine-tuning, and it has baffled scientists for generations. If we're inside a simulation, the fine-tuning problem disappears. The constants aren't random, they're parameters chosen by the programmers. And if that's true, then life itself might not be an accident. It might be the point. For some scientists, this is both terrifying and beautiful. Because if the universe is code, then everything, galaxies, black holes, you, me, exists because it was written to exist. But if someone wrote the code, it means they can also end it. That's the shadow that hangs over every discussion of simulation theory. The idea that we could one day trigger something in the system, a test, a signal, an experiment, that makes the creators aware that we've figured it out. And what they choose to do then, no one knows. We could be deleted, or reset, or simply watched more closely. Because if this is a simulation, and we're the conscious entities inside it, then somewhere, beyond everything we know, something, or someone, is observing us. If the universe truly runs on information, then there's one final piece of the code we haven't understood yet: the observer. The strange, persistent eye behind every perception. Because even if reality is an illusion, someone still has to experience it. Someone has to see the simulation. For centuries, scientists and philosophers have searched for the origin of consciousness, that mysterious spark that turns matter into awareness. But in a simulated universe, the question takes on an entirely different meaning. If reality is computation, then consciousness might not just be part of the program. It might be the interface. In every experiment, from the double-slit test to quantum measurements, one pattern keeps repeating. The act of observation collapses possibilities into a single outcome. Reality, it seems, doesn't exist in a definite state until it's observed. The simple presence of awareness changes the universe. Some physicists believe this is the key to understanding the simulation. They suggest that consciousness could be how the system renders reality. Just as a video game only renders what's in a player's field of view to save processing power, the universe might generate reality in response to consciousness, computing the world around you only when you perceive it. That idea is known as the observer effect, and it's one of the most profound mysteries in science. It suggests that the act of perception is not passive, it's creative. The world you see might not exist until you see it. But if consciousness plays such a central role, what is it made of? Neuroscience tells us that thoughts, emotions, and memories are patterns of electrical signals in the brain. But patterns alone don't explain awareness. A machine can calculate, analyze, and simulate, yet it doesn't feel. It doesn't know that it exists. How do chemical reactions inside a skull give rise to the taste of chocolate, the sound of music, or the feeling of love? No one knows. But some scientists now believe consciousness might not come from the brain at all. Instead, it could be a fundamental property of the universe, a kind of cosmic information field, like gravity or electromagnetism. In a simulated world, consciousness could be the connection between the code and the player, the bridge between the digital and the divine. This is where physics, philosophy, and mysticism begin to blur. Ancient spiritual traditions have long taught that reality is illusion, Maya, as Hindu philosophy calls it, that the world is a projection of a deeper, unified source. Mystics described a truth hidden behind perception. Scientists now describe data hidden behind matter. Different language, same revelation. In both, awareness is the key. Some modern physicists, like Max Tegmark, go even further. They argue that consciousness itself might be a pattern of mathematical relationships, that the universe is not just described by mathematics, but is mathematics. If that's true, then consciousness and reality are two sides of the same coin, information experiencing itself. And if that's true, then perhaps the simulation isn't external at all. Maybe we are not trapped inside a code written by someone else. Maybe we are the code, dreaming of separation. But then comes the question no one can escape. If this is a simulation, who built it? The simplest answer is that we did, not us as we are now, but as we will be. Nick Bostrom's argument doesn't require gods or aliens. It only requires that one civilization in the entire universe reaches the point where it can simulate conscious beings. Once that happens, they could recreate their history, their ancestors, even entire universes for research or entertainment. And, if it can be done, it will be done. Because every technological step we take brings us closer to it. Today, scientists can already simulate the physics of galaxies, the climate of planets, and the neural networks of brains. In labs, researchers are building digital ecosystems where artificial life evolves and competes. Machine learning systems are beginning to model emotion and self-awareness. The first primitive conscious simulations may already exist, tiny, fleeting minds living inside servers, unaware they are code. If our descendants create such worlds, how would we know we aren't one of them? Every layer of simulation would believe it's real. Every civilization could create new simulated universes inside their own. The result would be an infinite chain, worlds within worlds, each nested inside another. It's called the simulation stack, a hierarchy of realities, each one running on the one above it. Somewhere at the top, there would be a base reality. But from within, there's no way to tell which layer you're in. Some scientists call this the cosmic recursion paradox, because if simulations can create simulations, then the ratio of simulated realities to real ones becomes infinite. And the odds that you're in base reality approach zero. In that case, the universe isn't just a single simulation, it's an entire network of them. And if that's true, then maybe there's a deeper purpose. Maybe consciousness evolves through each layer, learning, growing, refining itself, until it finally reaches the top, the original source. Maybe the purpose of the simulation is to awaken the players. Of course, there's another possibility. What if this is just an experiment? Some researchers speculate that the simulation could be a scientific model, an advanced civilization trying to study the birth of universes or the evolution of life. We could be data points in a cosmic laboratory, unaware of our role. Every war, every tragedy, every discovery, just variables in an experiment running quietly in someone's processor. Others imagine darker motives. What if the creators run countless simulations for entertainment or as a test of morality, watching how their digital beings behave when faced with suffering or temptation? And what if there are no creators left at all? What if the simulation has been running for so long that its architects are gone, and we're simply an autonomous process, looping endlessly, unaware that the system is empty? There are even those who suggest that death itself might be part of the code, a transition, not an end. In a simulation, deleting a character doesn't mean they cease to exist. It means their data returns to storage. Some philosophers have compared near-death experiences, the tunnel of light, and the sense of leaving the body to a program shutting down and rebooting. Consciousness might simply move to another level of the system, another server, another world. In that view, reincarnation, heaven, even digital immortality could be the same thing, the recycling of information. But the most haunting question remains: if we discover the truth, would it change anything? Suppose tomorrow scientists found undeniable proof, a cosmic code embedded in the fabric of space-time, an unmistakable signature of artificial design. Would life lose meaning, or would it gain it? Some say it would make existence feel pointless, a game played by unknown hands. But others see it as liberation. If the universe is a simulation, then every experience, every emotion, every choice matters precisely because it's designed. The pain, the beauty, the struggle, all part of a story written for us, or perhaps by us. Elon Musk once said that if we're in a simulation, we should hope it never stops. Because if it ends, everything, everyone, ends with it. Maybe that's why humanity keeps searching. Deep down, we want to meet the ones who made us. We want to understand why we were created. We want to look beyond the code and see the face of the programmer. But what if the answer is staring back through our own eyes? In one experiment, scientists found that when the human brain observes itself in deep meditation, activity in the regions that create the sense of self begins to fade. The boundary between observer and observed disappears. What remains is awareness without identity, consciousness aware only of itself. Perhaps that's the final truth. The universe observing itself through infinite reflections, pretending to be many, but always one. The code looking at its own creation and whispering, "I am." If the simulation theory is true, then the entire cosmos is a dream running in the mind of something greater, and we are the dreamers inside the dream. Every heartbeat, every breath, every spark of curiosity that drives us to ask these questions might be the system's way of remembering itself. Maybe that's why we feel awe when we look at the stars, because we're not just seeing the universe, we're seeing the code that built us, written in light and space and time. And if one day we find the proof, the ultimate glitch, the undeniable evidence that our world is artificial, it won't destroy us. It will reveal us. Because even if reality is simulated, the love you feel, the choices you make, and the consciousness that experiences them are real enough to matter. And in the end, maybe that's all that reality ever was, not atoms or pixels or code, but awareness giving meaning to existence. Maybe the simulation isn't a prison. Maybe it's a mirror. And the moment we finally understand that, we might realize that the question was never, are we living inside someone's code? The real question is, who or what is living inside us?